So guys, this one says, suppose that the distance a fly ball hits the outfield is normally distributed with a mean of 250. Where did he go? 250 feet, and the standard deviation of, you already forgot, is it 25 feet? 50 feet. Lock it. If x is the distance in feet for a fly ball. Well, so which part of this do you have trouble with?
C.
Because the first question is really just what kind of distribution is this? And they tell you in the problem that it is normal. But it's going to be one of these situations. So it's normal, so what letter is going to go out here? That's crazy. Is binomial B uniform? Is W? No, I'm joking. And then what are the two most important numbers to know for a normal curve? Mean and standard deviation. So you would just put 250, 50. I don't know why I'm doing the problem for you, but it just happened. Enjoy that. If one fly ball is chosen at random, what's the probability that this ball traveled fewer than 220 feet? So if you haven't done this problem yet, try to write that probability statement. What's the probability that the ball traveled fewer than 220 feet? What would that look like as a probability statement? X less than 220. And that one, we've done problems like that. I'm not going to do that problem for you. You draw it, you put the mean in the middle, you make z-scores, look it up, blah, blah, blah. Why is this kind of nice? Because the chart tells me areas below, and the question wants the area below. Kick ass. I don't have to do any 1 minus shit. So here's the real question, part C. Find the 80th percentile of the distribution of fly balls. So what does the mean create? What percentile is the mean? 50th. Why? Because what percentage is below it? 50. What's the percentile always mean? If I'm in the 11th percentile of height, that means that only 11% of people are shorter than me, right? You guys with me? So the percentiles can never mean anything different. It doesn't matter what the situation is. If I'm in the 76th percentile, 76% of the data points are below mine, whatever that is. So it could be good, bad, I don't know. Depends on what they represent. How you doing? So what the hell? Where's P80 on this chart? Yeah, why has it got to be up here? Because this is 50% below. If I want 80% below, doesn't it make sense that I go a little bit up? Please let that make sense. Yeah, so then I pick up another 30% as I move. So where do I put, where's this go in the picture? Yeah, because it's a what? I love open-ended questions like that. It's the numbers. Now, what the shit you want from me? It's an area, right? It's not a z-score, so you don't put it down there. It's the area. So here's something I like to write down. Normal problems, traditional z-score problem. They give you a raw score. We take that and we make it into a z-score, right? With me? And then I look that up on the chart to get the percentage. Isn't that the normal? We've done that, by this point, you've done it a decent amount of times. We're going to do it even more today, just to make sure you really go all the way insane. This problem, you guys with this? Is this cool? We've done this before. X's, make them in a Z's, look them up. When am I allowed to look them up? When am I allowed to take this step? When it's normal. How are you supposed to remember that shit? Well, there's a normal picture on the z-score chart reminding you, hey, don't use me unless you have a normal curve. get? How do I go from here to here? What do I use to make an x into a z? Yep. Yeah. You guys with me? So this step is converting to a z-score, seeing how many standard deviations away to that data point. So that'll be the first thing you would do with that number, right? And then this step is using the chart when you're allowed to, and I'm allowed to on this problem because it is normal. Kick ass. Now, Hugh is like, well, what the shit about my question, man? You talking about that? All right. So yeah, let me write this stuff down. Here's the normal way I go. Where did I start in this process on this problem? What's the first thing they tell me? A percentage. So I'm here. So I got to go backwards. So I still use the chart to do this step, but I've got to do it backwards. I got to find 0.8 in here and go look out to get the z-score. Again, please let that make sense. What's that chart do? It converts z-scores to areas, which means it can also convert areas to z-scores. You can convert feet to inches, inches to feet. You can go both ways, right? Be jealous. Math can go both ways. There you go, Samika. So how do I go back? So I can look in the chart, get the z-score that relates to 80%, and then how do I make it go back to an x-score? Which formula? We can make a better one. We have the technology. That formula works really well if it's a z-score you want to calculate. What do I want to get at this point? I want to calculate the x-score. I'm almost certain we've done this before, but how do you solve this for x? Multiply by the standard deviation. All right. So I get z sigma equals x minus the mean, and then I add the mean. So then I would use this formula to convert backwards. So I use the formula to convert from x to z, and then I look up the chart to get the percentage. If I start with the percentage, I look it up in the chart backwards, and then I use the formula backwards, because I'm trying to get back to x. Hopeful, hopeful, hopeful. So how do you do this problem? Well, you look up 0.8 in the body, you get what that z-score would be. Can somebody tell me anything about that z-score? It's got to be above, so it's got to be positive. I like it. And then you plug that sucker into this equation along with the other things that we know. Okay, maybe. All right. Can't read your faces right now. All right. Yes.
Can we do another one?
Sure.
74 on chapter 5.2, letter I.
Oh, okay. This is one that I'm kind of happy you're asking this question, because this is a question that should be asked. It's a little bit weird. Let me see who's done this problem. Does it look familiar to you guys about a problem? All right. So if you haven't done the problem, you're just going to go, yeah, Jeff looks familiar. Oh, shit. Okay. Yes?
Why does it say 152 and 53?
The 53 doesn't matter worth anything. How wide is this? 52. So what's the height got to be to make it have an area 1 over 52? No?
Height times the width.
So if I had this,
Because I thought I always had to match, like, it would be 53.
no. If I had this, how do I make the area of that 1? Not 1 over 802. That doesn't make sense, because how wide is this side? 1. So the height could be 1.
Oh, but if it was from 0.
Yes, so we did a problem that started at 0. So that was the one time that it's 1 over the biggest, because that's how wide it is, because it's minus 0. But in general, some of you guys see this and recognize it. 1 over b minus a. That looks difficult, but it's just 1 over the width. the reciprocal of the width to make the area come out to be 1. Okay, I like it. I like it. Go. Jeff. All right. So this question, this is after a bunch of other probability questions. This one says, what's the probability that 12 is less than x, given that x, where'd you go, is less than 28? First thing I would do is turn this thing around. Do you see what it did? Because it's much easier to read what this means if the variable's on that side. Now, if I know that the time is less than 28, what times can I eliminate? Anything above 28. So how can I redraw this picture like that? So given that it's less than 28, well, how tall is it now? Whatever, 27. All right, that's a big step right there. So when I do a given, how do I always do givens? I focus on what it could be and I throw out what it can't be. So what happens when I throw out from 29 up? Well, now it becomes the height changes. And then you just got to do, how do you draw that in there? X greater than 12.
Find 12.
Find 12. Sure. So you're just looking for that area. So the given, the idea by the given doesn't change. The idea of a uniform curve doesn't change. It's just how do the two act together? Well, a given tells you what to ignore. I ignore everything above 28.
How do you know? Because I know sometimes you say like we're not supposed to change like the units. Like, does that make sense? Like we're not supposed to change it from 53 and 52 to 27, 28.
Yeah, not for a problem. Well, so what's the only time that the bottom of a probability will change? You can do this. If I gave you a big table and the total number of people was 128, every bottom of a probability is going to be out of 128 except for the problem that says what? Given. If I say the probability is given it's a woman, then I'm not going to use all 128 people. I'm going to make it the number of women. That's exactly what's happening here. What's the only thing I consider for this problem? Up to 28. So given that it's this, so I know it's got to be out of those 27 things. Hey, 1 out of 27. Okay.
But otherwise you would change.
The only time you can change things is if it's a given. Because then I can ignore what's not given. I can throw them out. Given as a woman, we'll throw all the dudes out, right? Okay, so that is a weird question. It is. But it's trying to show you the idea of a given. How does it kind of interact with a uniform distribution in this case? Yes?
So then would you make like the probability of x is less than 12 over the probability of x is less than 28 under that?
Why do you keep saying less than? 12 is less than x, which means x is greater.
Or greater than.
But you could do this in more disgusting ways. There's a formula for this, and the formula looks gross. I don't need the formula because I have the picture. It is much more direct. So when I have a chart, how do I do a given? I just cover the thing that's not given, and I just work with the other numbers. Does that sound familiar?
Yeah.
So here, I just cover the other numbers. In this case, I just erase them. Just work with what was given. So now my question becomes a normal uniform question. I know I just said normal, I mean a standard uniform. No, screw it. Just find the area given that it only lives up to 28. How do I know that? Because it freaking said given that it only goes up to 28. So what would it be? What's the width? 16 out of 27. You're lucky. Sometimes I just can't stop myself when I do a problem. Yes?
So if we draw that on our homework, are you going to accept that as showing our work?
It would be so evil if I didn't, right? See what I'm saying? And I'm not quite that evil yet. Give me a few more years, right? I said that a few years ago, but I'm still not quite there yet. So someday I'm going to just unleash and go, now's the time. Screw all of you. So this is exactly one way to do this problem. You could use the formula for this, but that would make it would work. It would totally work. It would just be a little bit grosser to look at than just doing it more directly. Yeah. Okay. Anything else from homework stuff? Yes.
Section
33, what section?
6.
Okay. Chapter 6. Right?
Yes.
33. Oh, I like it. So this one says, about what percent of X values lie between the second and third standard deviations? Both sides. So this whole section, I think, is assuming it's normal. So what it's asking for is this. Between the second and third, right? So between the second and third, but then it said both sides. Okay, like, is that cool? So then, if you can find this, you would just double it. How do you find this? Well, if you look up 3 and you look up 2, what are you going to do with those? Subtract. I like it. So don't let this side freak you out. If you figure this one out totally, how do you get the total area for both? You just double it because it's symmetric. You guys really, really, really hate me. It's okay. I'll survive. So, anything else from homework? 82. Is that what you said?
I guess maybe.
Oh, yeah. All right. All right. And in general, there are certain homework problems that if nobody ever asks me a question about it, either nobody's doing it or everybody's just giving some weird ass thing. This one's a little bit weird, but not too crazy. There's 2 different schools. Ricardo goes to one, so 2 different colleges. Call it College R and College A. Because this is where Ricardo goes, and this is where Anita goes. Good old College R. Ricardo's, so it says here, Ricardo's GPA is the same as his school's average. So Ricardo's GPA equals the mean. Is that cool to do that? You guys see what I mean? The mean of the art college. So what is Ricardo's GPA's z-score?
0.
Sweet. What's the z-score for the mean always? 0. Because what's the z-score tell you? The number of standard deviations from the mean to the number I'm talking about. I'm talking about the mean is 0 away from itself. It's almost too basic to get. It's like, that's why it's always 0 in the middle for z-scores, right? So this z for him is 0. They tell me that Anita her GPA is 0.7 standard deviations above her average. What do you use working better? So what's Anita's z-score? Yeah, it's just 0.7. They tell you what the freaking z-score is. What's the z-score tell you? The number of standard deviations from the mean to the data point. Well, how far away is her GPA from the mean? 0.7. All right, that's the z-score. Okay. does Ricardo's GPA, let me read it exactly how it says. Does Ricardo's GPA have to be lower than Anita's GPA?
So, how do you because you don't have enough information, do you?
No, you have enough information to tell if that has to be true or not. Not is it true, but does it have to be true? No. I love it. Two different colleges. Guys, everybody. Or, if you're talking, just don't talk too loud that people can hear. Do the colleges have to have the same average GPA? No. This college could have everybody there is insanely academic. Right? They just study the shit out of books. They don't have a clue how the real world works, but they know their book and learning, right? So maybe their GPA at College R is like 3.85. So Ricardo's GPA, their mean, let's say, could be this. Where did I get that from? Out of my ass, right? So I'm just trying to say, does this have to be true? One way to answer this is to set up a situation where it isn't true. So why do you think they asked this question? You see, his z-score is 0, and her z-score is 0.7. You go, well, that's bigger. But what average? Are they based on the same average? No. What if this GPA was 1.98? Their average GPA there at that good old College A, right? She's above average, but she could definitely still be below Ricardo. So the main thing there is you don't have a clue what the mean at either college is. So the question isn't what is the answer. The question is, does it have to be true? Could it be true? Sure. Does it have to be true? No. Bye-bye. Bye-bye. Let's see. Oh. So it says the next one is kind of silly. The next one says, Ricardo, is it true? Does it have to be true that Ricardo is not passive? Because his z-score is 0. No, because again, if that's the average grade, holy shit, I would hope that's passing. Oh, you're doing terrible, man. You're averaging it. A minus, that's just bullshit. Holy shit. All right, you guys semi with me? A little bit? And then part C says, Anita is in the 70th percentile. Is that true? Can anybody figure out what percentile she's in? You have exactly enough information. Well, let's see if you do. If I add one piece from the actually. If I said they were normally distributed. Where is her score? Where's her GPA? What's this? 0, because all I know is z-scores. Where's hers? There. Is 0.7 70%? No, because it's a z-score. How do I figure out the percentage?
50% is 0. So
Sure, but you can get exactly what percentage, can't you? Don't you have the sheet of all the answers? Don't you wish every teacher gave a sheet of all the answers? Yeah, you just have to know how to use it. Oh. So if you look up 0.7, can you tell me what percentage that is? 7580, right? So she is not in the 70th percentile. She's almost in the 76th percentile. You guys see that? Maybe. It's like, what a z-score of 1.1 mean you're in the 110th percentile? No! How the shit is that true? I'm better than 110% of the... So you're better than some imaginary people too? What are you talking about? All right. Maybe. So I love that problem because it is more conceptual. And that's exactly why students kind of dislike that kind of problem. But you've got to understand the idea behind these things. 0.7 is not equal to 70% in this case. It's a z-score. It's not a percentage of something. It's a position. Okay. Anything else from homework? All right, so what I want you to do, this is going to be a little more bare bones, a little more nuts and bolts. So don't do this side yet. We're going to do this side together, the one with all the colors, all two of them. do this side. This talks about rents, prices, rents in New Zealand and San Diego. Why? Because that's how I made it. That's why. Let me pass these out, and then if you need to borrow a calculator, come up after I pass these out.
Which side, Mr. Ron?